So I will be doing problem number 33 from chapter 6. A 9 kilogram object starting from rest falls through a viscous medium and experiences a resistive force R equals to negative PV, where V is the velocity of the object. The object reaches one half of its terminal speed in 5.54 seconds. Determine the terminal speed. At what time is speed of the object 3/4 of the terminal speed? How far has the object traveled in the first 5.54 seconds of motion? Okay, so firstly, this is our free body diagram. The only forces that are present is the mg and the kb for the resistive force. And we are given that when velocity is one half of the terminal velocity, that happens at t equals to 5.54 seconds. And now we want the terminal velocity. Now, in order to get the terminal velocity is equal to mg over k. That's our formula. So we have m and we have g, but we don't have k. So we're going to solve for k now. We use the formula v equals to mg over k times 1 minus e to the negative k over m times t. So instead of v, we have 1/2 of vt equals to mg over k times 1 minus e to negative k over 9 kilograms times 5.54 seconds. And notice that the terminal velocity is equal to mg over k. So terminal velocity and mg over k are here. They cancel out. So we will get that 0.5 equals to 1 minus e to negative k over 9 times 5.54. And you just put that in your calculator and solve for t. And here's how I did it. It's just 1 minus e to negative x times 5.54 over 9 minus 0.5. And then you just, nope, wrong graph. So this is the right graph. So you just graph it and then you calculate the 0, which will be just gonna be there in a second. There and there. So 1.126, we just round that up to 1.13. So your k is equal to 1.13 kilograms over second. Now we have all that we wanted. So Vt is equal to mg over k, which is 9 kilograms times 9.8 meters per second squared over 1.13 kilograms over second, which you will get 78.1 meters per second. That's your terminal velocity. So for section B, it asks that at what time is the velocity 3/4 of the terminal velocity. So we just use this formula again. So instead of v, we put 3/4 of terminal velocity is equal to, and then instead of mgk, we substitute v terminal velocity times 1 minus e to the negative 1.13 over 9 kilograms times t. These two cancel out, and then you just put it in your calculator again. This time it's the second one, 1 minus e to negative 1.13 over 9 times x minus 0.75, and you just graph it. Once you graph it, you just calculate the 0 again. So this is the left bound and this is the right bound. Your 0 is in 11.04 seconds. We just put that 11.0 seconds. And the 11.0 seconds, that's the answer to part B. And for part C, it asks you what is the distance that the object traveled at time t equals to 5.54. So we just take the antiderivative of the our v formula. So you get delta x is equal, so we just first distribute to get it easier. You get mg over k minus mg over k times e to negative k over m times t. So the antiderivative of the first term is mg over k times t, and then the antiderivative of the second term is the m2 g over k2 times e minus k over m to t, because because of the chain rule and the fact that the derivative of e to the x is equal to e to the x. And then also let's not forget that since you're taking the antiderivative, there's going to be a constant here. Now we're going to solve for the constant. And in order to solve for the constant, so in the problem it says that the object starts at rest, which means that at time equal at t equal to 0, your delta x is equal to 0. So you substitute 0 for t, and you get delta x is equal to 0 is equal to m2 over g over k over 2 plus c. So your c is equal to negative m2g over k2. So, and you just substitute c back in your equation. So this is your delta x equation. And you just put all the numbers in, and you get this gigantic mess. And you put that into your calculator, and hopefully you will get something like 120.8 meters. That's it.